This is the video for CS 121, Chapter 5, Part 2. So in this challenge activity, we want to be able to print numbers, one right after the other, which makes sense. For loop, I could print number 1, 2, 3, 4, 5. But I also want to include a second character, a letter, A, B, C. Now I remind you that the characters were in 2.17, and capital A starts at 65. So that gives us a real short way to do these nested loops, being able to print out numbers and letters. So I need a loop for the range from 1 to the number rows plus 1, because remember number rows would not be included. So 3 would not be included, so I have to add 1 there. And then I want to start at 65. I want to go from 65 to 65 plus the number of columns. So it'll give me 60, it looks like 8 for this one. So 65, 66, 67 is what I'm wanting. If I do string of the range here and add, this is concatenating this part, character of the columns with a space in between, then I can get these printed really quickly. I passed all the tests, 1A, 1B, 1C. So you could have declared a whole lot of variables, spent a lot of time, but sometimes simple things like knowing a little bit about the Unicode characters will help you to do your loops pretty quickly if you're wanting alphabet characters, or any other character for that matter. 5.9 is talking about how you develop programs yourself. Now I follow this thing they're calling incremental programming. I'll put a little bit of the code together, run it, see if it works. Put a little bit more together, run it, see if it still works. See if I haven't broken anything. So we have an example here of the phone number program. So the first thing is to be sure that we can actually print all the characters in the phone number. So this little program here prints all the characters in the string that was put in. So it's not recognized as a phone number at this point. It's just a string that came in. This is printing at index 0 first, and then it's incrementing the index. We also have a for character in the user input. So this is going across each character in the string. And the word character could be any variable. It could be just C. It could be str, anything you want to put there. So that's not, I don't like that they use the word character in there, because we're looking at characters and it makes it a little harder to see what we're doing. The next part of the program is to check to see if we can identify when we're not looking at a number. So this says if 0 is less than or equal to character is less than or equal to 9, so it's looking at the characters from 0 to 9. So that harkens back to this Unicode. The characters 0 to 9 in Unicode are straight up in the number sequence here. So you're looking at the characters 0 to 9, not the numbers 0 to 9. So looking through the characters, I'm going to put the phone number in as a character itself. Otherwise, I'm going to put a question mark in. So notice the plus equals. It starts with a phone number that's blank, and then it's adding each of the characters that's actually a number. So the next part of this program is to put enough in so that it handles one of the keys on your keypad. So the typical telephone keypad would have 2 for ABC, and so on, D, E, F, G, H, I, J, K. So you'd have to add all of this functionality to be able to turn those numbers into numerals, or the letters into numerals for this program. Notice that they're also checking for both uppercase and lowercase, because those are different characters on the Unicode. So looking back at the Unicode, A through B is 97 on, 65 on is starts with a capital A. When you fill in the rest of the if-else branching, then you get the final version, which if you put in an actual phone number with correct numbers and letters and dashes, or whether they're lowercase or uppercase, it doesn't matter, or just letters, no spaces, with dashes, then you end up with a phone number. Anything else is going to give you some garbage in, garbage out, right? In 5.9.1, to actually complete this program, so all I really need to do is put in the rest of the if-else. So the elifs, pretty much copy down the page, Control-Z. I'm going to go home first to do it. all the way down for all the characters. So you go through here and change. Now we have D through EF. Capital D through EF. This would give me 3. So it's some tedious work, but it's kind of interesting to see that that's all you really need to do for this kind of program. There are lots of other ways that I would do this. I might have put this in a key or a list and worked with it that way. Break statements and continue statements allow us to exit a for loop before the whole loop has been completed. So with a break statement, if you're in the middle of a loop and you have a break, it'll exit the for loop that it's in. So the first break here exits this for loop, and this break is inside the larger for loop. So this program is trying to figure out how many empanadas and tacos you can buy for a fixed amount of money. So it's trying all possible combinations of empanadas and tacos. So you can look through the code to see how that is considered, and then it checks it against how much money the user has, and they have to be exactly the same to jump out of the loop. Once you're out of the loop, then you'll print that you could buy tacos and empanadas. While the break jumped out of the loop, the continue statement jumps back to the header. So this first continue statement here will go back to the header here and increment the number of empanadas and put that through. So once it hits this continue statement, if the rest of these are inside that loop, and they are in this case, the rest of the things that are inside the loop for which that continue statement appears, then the rest of the lines of code will not be executed until you increment the number of empanadas. For the challenge 5.10.2, you want to compare two strings, one that Simon put in and one that you're putting in. Simon's input and your input. So the computer is coming up with some string, and you'll go straight through the string, and remember that you compare the string Simon pattern by putting a bracket with an index in it. So you have a for loop that's going to go through 10 characters, sequence of 10, and if it doesn't equal, then you're going to break. If it does, then you update your score. Then you print the user score when you're done. 5.11 introduces a structure called a loop else. So if you have a loop, it can optionally include an else clause that executes only if the loop terminates normally. So if you go through your while loop completely without breaking, then it'll next execute the else. This feels a little backwards to me because if I have an if, an elif, and then an else, if all the ones above were false, then it's going to execute. Although technically that means that if all the ones above were false, you went all the way through the entire if structure, then you'll do the else. So it's kind of the same, but it doesn't feel like it to me. It feels a little backwards. So you may share that with me. Share that feeling with me. So if you do the entire while loop without bumping out of it, without taking a break, then it'll execute the else immediately following that while loop. You can also use an else in the for loop. So if you go the entire for loop, iterates all the way through all of the iterables here, then it'll hit that else statement next, and it will execute the else. If you break out of it, it skips the else. There's a short example here that if you put in 2 now is the number that you want to print, the number of names to print. There are 5 in all, so when you do for I in 5 of them, notice that it's printing up to just 2 because it's going from I in length's name. If I equals number, when it gets to I is in lengths, that would be 0, 1, 2, Martin. Martin isn't one that I want to print because I want 2 there, and Martin is 2. So they're equal. So I'll break out of the for loop, and it breaks out of the else also. So it won't print all names printed. The other case they give us is 8. So if num here is 8, there are only 5 of these, so I'll never hit I is equal to num because the largest I is going to be is 4. Because it's going to use 4, it doesn't use 5. It only goes up to 4, the length of the names. So it doesn't go to 8, so it doesn't break out of here, so it doesn't print this, so it will print this last statement. So it never broke out of the loop, so it does print the else statement. So else only happens if you haven't broken in the loop. 5.11.1 introduces a couple of interesting concepts here. The country of Denmark only allows around 7,000 names for newborn infants. It seems to be in the last 30 years or so, people have come up with more and more interesting ways to spell names, which can be very confusing for elementary school teachers and for college professors too. I'll give you that. But here we also have another thing, something called a string edit distance. It calculates how many characters are different between two strings. So there's an import involved. Import the edit distance, and then edit distance between the name that is on the list. The name that's on the list. See, this name is in legal names, and the username, the one that the parent or prospective parent is putting in. So that has to be less than 2, which means that there are less than 2 characters that are different. So less than 2, I would think, is just 1 character, right? So let's make sure that's true. For example, the edit distance of dog and dig is 1 because you changed the middle character. So it is about how many characters are there. So you might play with this for a little bit. I know my name is not on here, so we'll see what happens with my name. Not acceptable. No close matches. So my name will not fly in Denmark. Of course, this isn't the entire list. A typical thing you want to do is go through and get the values from a list like this. So in 5.12, there's a couple of examples here of ways that it's been done in the past, but they're also going to introduce the enumerate function. So for this list origins, it has 3 elements. So the length of it is 3. The indices are 0, 1, and 2. So here the lengths of origin is 3. So the range and the lengths of origin means I'm going to go to each index in here, and here I'm going to print the index and the value. So element 0 with colon in it, index and value. The braces here are empty because there's no particular format that we're applying to the element number and the value number. We could also go through the list by doing a for loop over the actual elements in. So for value in origins, so that's each one of the values in there, 4, 8, and 10. Here it was for index in the range, so we're looking within 0, 1, and 2. So they're only slightly different. Index is going to be the origins.index of the value, so we're getting the index out for each element. And the for loop will go through the 4, 8, and 10 and print out the exact same thing we printed before. So those are pretty typical ways to get all the elements and indices from a list in programming. So we see another way to do a for loop here. The enumerate function is going to retrieve both the index and the value. So these are variables, index and value. I could have put just I and V in here. You don't have to put the words index and value, but probably it's typically done because then you can see for sure that you meant the index of origins and you also meant the value that's in the element at that index. So this says enumerate, that's our new function, the list. So we're going to enumerate the list, it splits it up so that we can see those two. This is a process called unpacking. So looking at the challenge activity 5.12.1, we can see that we have the same kind of setup again. We have 4 in enumerate colors. So this enumerate is the function name. The colors is the name of the list. These 2, position and color, have to do with the index and the element. Index and element is always in the correct order here. You can call them anything you want to, but index and element. And then, of course, you could print them out backwards if you want to. The 513 additional practice is a bonus point. It's worth 20 points. Due Sunday before 5 o'clock. Be sure to follow the directions very carefully underneath the code that's given to you there. 4.14 lab is converting to binary. So they give you the algorithm here. As long as, that sounds like a while, as long as x is greater than 0, so while x is greater than 0, you're going to put the x modulo 2, so the remainder. And then you're going to assign x to be x divided by 2. So basically this is the pseudocode. They told you exactly what needs to be written here. Your print statement will happen every time. So you're printing and you'll have an end with no spaces in it. So if you remember what that looks like, I'm going to be printing something. Whatever I need to print here, my variable. And then I'll have a comma and an end with no spaces. In 5.15, you have some input that's going to be a string, and it might have spaces, periods, or commas in it. And you want to know the length of this without spaces, periods, or commas. So we know how to find the length of it. And there are several ways that you could do this in order to determine the length. You could actually remove the commas, though in strings you can't remove the commas. So you'd have to rewrite it every single time. But you ought to be able to count those commas, periods, or spaces. And with an or in there, that gives you kind of a hint of how you'd set up your logical statement. In 5.16 lab, the password modifier, we're going to take some expression that's being put in, some string that's put in from my password perhaps, and everywhere that we have an I, A, M, capital B, or an O, we're going to replace it with some other character. So I know for sure I'm going to need this in my code somewhere. And I think the way I'd like to do it is to put it in as a dictionary. So it takes maybe 3 more lines of code to get this completely checked out for each character that's in my word if I use the key and value system for a dictionary. You may just use an if-elif statement and write yours that way, but I did find a quick way to do it with a dictionary. So for 5.17 lab, you're going to output a range with an increment of 10. Now the range is actually going to be -15 to 30, 10. So it's telling you exactly what the range is supposed to be. So you'll print out for each one of those, starting at -15, you'll just print this out, and they say to put a space in between them. If the first integer is actually larger than the second integer, then you're going to print out the second integer can't be less than the first. So I'm going to go ahead and copy this down, Control-C. Copy this down. I know I'm going to have to print this out. So I know I have an else. Oops. And that's going to be print second integer can't. And I've got to use the escape sequence for that. I could have used the double quotes and not had to use the escape sequence. So I know for sure I have that. So I've got input coming in, 2 integers, so I'm just going to put first equals int input, and also the second equals int input. So that's a fairly standard way that we're going to start the program anyway. It gets some input in, and then I know what's going to happen if there's a problem. So if first is less than second, then I've got to go all the way through the list starting with the first. So for, I'm just going to put I in range first, so that's where we're starting, second, and then we're going 10. Now I know I have several typos in here, so let's go back up. Well, first of all, n shouldn't look like this. It should be equals with no parentheses, right? So I'll let you fix that. The next thing is an increment of 10 as long as the value is less than or equal to the second integer. So value, the first value is less than or equal to should be there. And remember that the range is from the first to the second to the next one minus 1. So I'd actually have to put a +1 in here. I also know that after I get through this if, I'm going to need a print. Well, this is 4 here. I'm going to need a print here to go to a next line. For the 5.18 lab, we want to print a string in reverse. And there are lots of ways to do this, but there's a really short, quick way too. So first of all, we're going to need input from the user. So I'm just going to call str equals input. It doesn't ask for any prompts here. I would prefer prompts, but it's not asking for them, so we're not going to put them in. So while we need for the string not to be any of the 3 things. It can't be this, this, or this. So that means I need to do some nots with some ands. While string is not equal to quit, and string is not equal to lowercase, and string is not equal to Q. Now I could have made a list with this and then just check to see if it was in the list, but this is okay too. I need a colon. All I want to do is print out the string in reverse. So I'm going to do for I in, and I want to range. I want to start at the length of the string. So it's length of string. But remember that the length of string is actually one more than an actual index. So I'm going to do length of string minus 1, comma, down to 0. That's the last one I want to do. And I may need a negative one here, comma, minus 1. So I'm going to go through the string backwards. All I want to do now, oops, forgot my colon. All I want to do now is to print out the character that I'm on. Print string at the character that I'm on, at I. So I'm starting at the end of the string and working down, decrementing. That -1 in the range here tells me that I'm decrementing and going down. And I don't want any spaces, so I'll put end equals and empty quotes. And I'm pretty sure this needs to be -1 because I want to go all the way down to the 0 element, and then one more is what basically needs to be in the range here. So one more would be one less because we're going down. We also need to put a print, a line on, an empty line, so that we go to the next line, because hello there and hey and quit up here are printed one line after the other. And then we'll ask for the prompt again. So string equals input. And that should work. So let's try running that. Submit mode, submit for grading. And it says I've got an invalid syntax error. So that may mean that I left something off on the previous line, so we'll go look at it. And I did, I left off my parentheses. So submit for grading. And everything worked. So I know there are a few places where I'm typically going to make mistakes. I sometimes leave off my colon, sometimes I forget to put my quote in or my in parentheses. Sometimes I forget to put a next line print, an empty print. So just be aware of where you're liable to leave things off in your programming. You'll be able to debug them a lot quicker. Basically, when you're programming, it's called bugging. And when it finally works, you've debugged it and it works. The 5.19 lab, once you start with an input of a number, and you're going to count down until the digits are the same. So there are going to be a lot of ways to work this. So think about this for a few minutes. You could use some percents and check characters. You could actually check characters at each of these if you're thinking of your input as a string. Even though it's an integer, you'll be counting down the integers, but you could check characters with a string. So I think that's what I'll do. Lots of ways to do that. We want to make sure that if the input is actually, the digits are the same, then it actually does print out the digits being the same. And if the input isn't between 20 and 98, inclusive it says, then we don't want to go through the loop at all. And you'll have to say the input must be between 20 and 98. So I'm going to go ahead and copy that because I'm going to need that. So down here somewhere, print the input must be between, so we got that done. We need an input. It didn't want a prompt, so I'll just put number, n equals integer input. Now I want to check to see that it is a number between 20 and 98. So if n is, I actually want to be 20 is less than or equal to n, which is less than or equal to 98. There are a lot of nice features in Python here. Then we'll do this. Else we'll do, so this is an else. Else we're going to do this, and I'll need an indent there. It asks me to compare the digits, so I'm going to actually separate the digits. So I have n1 is equal to n divided by 10. That would give me the first digit. And n2, I'm going to put n percent 10. So that'll give me the second digit. And it equals. I know that I want to print the number regardless of whether the digits are equal, so it needs to be printed at least. So I'm going to go ahead and print here, print n. And then it'll go down to the next line. I want to make sure we want it on one line. We want it on separate lines, so that's good. So somewhere in here I need a while loop or a for loop. So I think I'll do a while. And I'm going to use my variables. n1 is not equal to n2. So I can use these variables that I just created. Each of these is going to need to go over because I'm in a while loop now. One too many. And it will fuss at you if you add one too many. So I'm going to have to also initialize my variables. n1 equals, I'm going to put n1 equals to 0. And it doesn't matter. And n2 equals to 1. So they're not equal is all I want. When they become equal, then I'll stop printing. So I'm going to print and I'm going to take out the division and the remainder, and then I'm going to go down 1. So I'll do n minus equals 1. So I think that will do it. I'll try that. And I did get an error, and it alluded to the colon that I tend to forget. So we'll try it again. And this time I got a perfect score. So there wasn't a lot I had to do here. There's a lot of ways I could have done this. But basically I needed to separate the variables and check them every time to see if they're actually equal. If they're not equal, then I stop printing. In the 5.20 lab, we have an equation solver. So we want to do it brute force by trying every number between -10 to 10 for both x and y. So every possible combination between -10 to 10. So what is that? 20 by 20 is 400 possible combinations. Now, if you're going to try all of something, that really sounds like, they already said it, a range. It already sounds like a range. You're going from values and you're trying every single one for x's and y's. So we know that there are a lot of ways to solve these. If you had two linear equations, we have two variables, two unknowns. We can use substitution, elimination, Cramer's rule. We can work with matrices and do row-reduced echelon forms. There are a lot of ways to solve these. But what they want to do here is say that these are the coefficients. So it's 8x plus 7y equals 38, and 3x minus 5y equals -1. And all we really want to do is see if they actually match. So I'm putting 8 times my number plus 7 times my number and seeing if it's 38, 3 times the number and -5 times the number and see if it's -1. So I have 2 x's that I'll be trying and 2 y's. So it'll be 8 times your x and 7 times your y. So whatever numbers you're getting in here. We're also supposed to write no solution if no solution is found. So let's try that. Down here, I know I'm going to have to print no solution end. And that's probably an else. So that I have so far. So we got input coming in. We have x plus by equals c, and we're going to do 2 for loops. So we're going to do the for loops for all the x's and for loops for all the y's, and we'll need to have a break somewhere in there if we actually find our solution. So for, I'm going to put x in range, and this will be -10 is where I'm starting, -10, and I'm going to 10, which means I have to put 11 here, and I'm going to increment by 1 so I don't have to increment there at all. And for y in same range, -10, comma 10, we just have an if statement here. If we've got A, B, C, and D, so we need A times X plus B times Y is actually equal to C. We need for both of these to be true, and for the second one we have D, E, and F. So same thing, D, E, and F. D, E, and F. So if these are true, then we're going to want to print the solution. So the solution will be, the output will be like this. You'll print out your x and your y. If we never find it, we want to break in here too, right? So we're going to print something and we're going to break. So I have all the concepts you need in here. The break may need to be in a different place. Else for the print may need to be in a different place. But I think I've put everything in you need to, so I'm going to leave the rest for you. In the 5.21 lab, you want the smallest and largest numbers in a list. This is a really easy program because you're just going to increment through a list. And well, not even have to increment, because you have the list functions of append, so you can add a number to a list. So as you're reading these in, you can add it to a list, but it's append, not add. You also have a minimum and a maximum that you can use in a list. There's a sentinel character here. Integers greater than 0 is what you're going to be putting in. So make sure that when you're putting in input that you're putting in some integers that are positive and then something that is below 0. The 5.22 lab wants to put values in a list that are below a user-defined amount. So the first number here, 5, is saying how many numbers you're going to put in. So then you'll put in 5. And then after you put in those 5, you're going to put in a number. And it's the last value indicates a threshold. So I'll put all integers less than or equal to that last threshold. So that sounds like an if statement. So let's do this one really quickly. So I first want to get some numbers in. So I need the amount of numbers I'm going to get. So I'm going to put this as n equals integer input. So I've got that in. And then for I in the range of n plus 1, no, just n, right? It starts with 0. Let's actually start with 1 because it's easier for me to see it. N plus 1. So that's going to give me the numbers from 1 to 5 in the example they gave me. I want to do another input. So I need a list here, the 5 integers in the list. So I'm going to need a list. We'll try it this way and see if it works. So my list my list.add, I'm going to put an integer input in here. We'll see if this works. So I'm going to add an integer input, and I'm going to do that 5 times. Now I may need to begin my list. I may need to say that I have a list. List equals a blank list. And you can try it with or without that and see if that works. Now I've put my list together, so now I have these numbers. Now I want the last thing. So this would be what they're calling is the threshold. So I'm just going to call it threshold. So threshold equals integer input. So I want my list value, so I'm going to say for k in my list, I forgot my colon up there, so go back and fix that. For k in my list, if k is less than threshold, then I'm going to print k, and then go to the next line. So just going back and checking, I want a number coming in first, and I have that. I want 5 numbers, well, however many these are, coming in next, and I've written code for that, and then I have a threshold. So we want to get the last value, output all integers that are less than or equal to, and I think I put less than, so I'm going to put less than or equal to that last threshold value. Less than or equal to. So the first number coming in, I'm going to make a list. I want to go from 1 to n plus 1 and add. So this made more sense to me. Instead of this, if I just put range of n, that would have been fine too, because that would have given me the numbers from 0 to n minus 1, which would have been exactly what I wanted here too. So let's try this. And I had a couple of errors that I needed to fix. List is an append, not an add. And apparently I needed to do an integer input first. And that makes sense, because in programming you're going to ask them for something and you're going to put it somewhere. So I put it into my list here. Everything ran beautifully then. No test failed. 5.23 is very much like the previous lab, only you're going to tell how many values you want and get in those values. There is no threshold being given. And you're going to find the minimum, which is a function with list. So you can subtract the minimum off of each of the list values and then print out the output. For the 5.24 lab, we want to draw a triangle like this, using a specified character from a user and a height of the triangle. So here, they're giving you what this should look like if you're doing a triangle character, enter a character, and then enter the triangle. So they put those two in there. Of course, they're using a character with stars. Now, I would do this a little bit differently, because I really only need to add some things to what I'm printing every time and use a for loop to do this. So if I was given 1700, I should be able to print out a triangle with 1700, a height of 1700. So let's put some for loops in here. So the characters coming in, you want to print a blank line first, and then you're going to start adding characters to it. So I'm going to start with the dummy variable of, let me put my symbol equals blank. And in here, I'm going to print the symbol instead. Now each time I'm going to update my symbol so that I'm adding the input character to it. Symbol plus equals triangle character. So I'm going to do that for the number of times that I need a triangle height. So it's starting with, this would be 0 all the way up to 1, 2, 3, 4, 5, if I had 5. So I want to do for I in range, and I want to go up to my triangle height plus 1, because remember it won't use that last number that you put in there, so I need one more than that. So these will need to be indented. So I print the symbol and I've got the whole triangle there. I'm inputting. The first one's going to give me a blank line because I'm printing it. That's the 0 line, and then I'm printing the rest of the triangle. So let's see if that works. So it said that mine differs because my white space isn't quite right. So I need to add a space after each one of these characters. And I suppose there are several places I could add this space, but I think I'm going to add it right here so that it's at the end of my symbol, because I need to keep it every single time. Plus, it might be the only place to add it, really. So I'll put a space like that. We'll try it again. And I passed all the test. The last lab in Chapter 5, 5.25, is drawing half an arrowhead. So you'll be given the arrow base and width. So this is 5 by 2. And then the end of the arrowhead width, and you go all the way down to only printing 1 star here. So there's 4, and then it goes down, taking 1 star off at a time. So for loops here will be very helpful. The last program that we just wrote, the previous lab, will be helpful also.